So right now, in this section, right, we are going to marry the concept of your simultaneous and the discriminant. So previously, when you were doing the simultaneous, okay, like I mentioned, right, you could possibly get two answers, or sometimes you can get one answer, or you can get no answers. Okay, so the solution for simultaneous is the point of intersection, is the coordinate of the intersection. So the nature of, so when you execute the simultaneous equation, you will reduce it to a quadratic. So in the process of performing your simultaneous, you will reduce it to a quadratic equation. So the quadratic equation from there on, we can deduce the value of the discriminant. That means after you perform your simultaneous, you will be reduced to a quadratic equation. And from the quadratic, I can deduce the value of the discriminant. So the value of the discriminant is going to be telling me how many intersections are there. So when the value of the discriminant is positive, that means when you perform the simultaneous, there will be actually two solutions. So there are two intersections. So the two intersections are equivalent to two roots. So these are equivalent to two roots. Okay, and that's why it's considered two real and distinct roots. Okay, so sometimes when you do the simultaneous, you can only get one answer. You can only get one answer. So that one answer is actually one root. So there's only one intersection. In this case, there are two intersections. So two intersection is two roots. One intersection is one root. So when that is the situation, when there's only one root, it is like real and equal. So it corresponds to a discriminant being zero. So it's like two real and equal roots. So sometimes we call it repeated roots. Okay, again, we can have two real roots. So two real roots, right, is like these two situations. It can be real and equal or real and distinct. So we combine the two conditions. So it can be two intersection or one intersection. So sometimes in the situation of one intersection, so in this situation, sometimes we call it a tangent. So later on you will see this word tangent. So the word tangent is also an implication of one root. So the word tangent is an implication of one intersection, which is one root. So it leads you back to the discriminant being zero. So sometimes when you try to perform the simultaneous and you actually get no answer, you realize that it doesn't cut at all. So you realize that there's no intersection. So no intersection is like no roots. Here, no roots. That's why the discriminant is negative. So upon performing the simultaneous equation, you end up with no roots, you end up with one root, or you end up with two roots. So we can use the two way to tell. So we can tell from the value of the discriminant whether the intersection will give you, whether your simultaneous can give you two roots, one root, or no roots. Or it can be the opposite idea. They tell you how many intersections are there. You reverse the condition of the discriminant. Okay, so I'm going to show the idea using some examples. So if you look at example 5, okay, we got a line that does not intersect the curve. Okay, when it does not intersect, it means that there are no intersection. It means that there are no roots. It means that the discriminant will be negative. So right now, they are indirectly telling me that the discriminant is negative. And I'm supposed to execute the discriminant. so that I can answer for the range of values of K. So if I do need to execute the discriminant, I must get my ABC. So this time around, my ABC is obtained from the simultaneous equation. So you perform the simultaneous equation. It is the same technique. You get a subject from the linear and you sub into the non-linear. So in this case, right, the linear one has already gotten a subject. So I'm just going to put the linear subject into the non-linear. So when I do that, I get a quadratic equation. So when I get the quadratic equation, I'll be getting my ABC. So I'm getting my ABC. So I'm getting my ABC to perform my condition. So I will do a little bit of explanation. Since the line does not intersect the graph, does not intersect the curve, there are no intersection, meaning there are no roots. So the idea of no roots means the discriminant is negative. So after you execute, after you do the explanation, and after you gotten your correct ABC, you execute the condition. So you execute the condition, and you should find the range of values of K. So remember, if you are dividing by a negative number, remember to reverse the sign. Okay, so in the second part, we mentioned there is a tangent here. So just now I mentioned the idea of a tangent means, right, it actually looks like this. It touches the graph. So when it touches the graph, the idea of tangent is one root. So the idea of tangent for the second part is one root, and the condition for one root will be the discriminant being 0. So that means, right, if you perform all over again, if you perform all these over again, you will get K equal to 17/4. Okay, you can try performing everything again. So it's the same ABC. So usually you will still be using the same ABC, but you do not need to repeat because the instruction is a state. Okay, so the intersection is the idea of how many roots, and how many roots leads you back to the condition, the discriminant condition. But in this situation, if you need to get your ABC, you got to perform the simultaneous to get your ABC first. So in the next example, okay, I got a line and it is going to intersect at 2 points. So in a way, right, I know that there are two intersections, and that is the implication of two roots, and it is the implication where the discriminant will be positive. So from the idea of intersection, I relate it to the roots, and after I relate it to the roots, I deduce the value of the discriminant. So I'll be executing the discriminant so as to answer the range of values of P. So before I can do my discriminant, I got to execute the simultaneous first. So execute your simultaneous. linear into the non-linear, get a proper quadratic equation. So the idea of the quadratic is meant to extract out your ABC. Okay, once you extract out the ABC, you can do an explanation. Since there are two intersections, so there will be two roots. So meaning the condition of the discriminant will be positive. So you execute your discriminant. So you execute your discriminant with the ABC that you have found from your simultaneous. So that is the answer. Okay, in the second part, okay, the straight line become a tangent. So again, like I mentioned, tangent means, right, the straight line and the curve will just touch each other. So tangent is the implication of one root, and one root is the implication of discriminant being equal to 0. Okay, that means, right, you repeat everything here and you will be equal to 0. So you will be getting this as a solution. So you do not need to redo again. Again, the instruction is a state. So just by looking at it, and if you have the condition in your head, you can actually get the answer straight away. Okay, so in the same way, right, I'm going to answer this kind of question. I'll be using the discriminant to answer this kind of question. So in example 7, we would like to determine whether the straight line intersect the curve or not. So that means, are there any intersection, which is like any roots? So they are essentially asking you, is there any roots or not? So in order to tell if there's any root, I'm going to judge by the discriminant, the value of the discriminant. So in order to use the discriminant, again, I got to perform the simultaneous first. Linear into non-linear. So perform the simultaneous so that you can achieve your ABC. So once you got your ABC, I'm going to deduce it from the value of the discriminant. So this time around, if you look at your ABC, all are values. That means, right, you will be able to obtain a value by punching calculator. So if you punch calculator, you get a very negative value. So what is the implication of negative discriminant? That means, right, there won't be any roots, meaning, right, there won't be intersection. There won't be intersection between the line and the curve. That means, right, if you continue to try doing the simultaneous, you actually couldn't get any answer at all. So we determine the solution if there's any intersection based on the discriminant, because the intersection is equivalent to roots. So roots will lead us back to the discriminant. So like I said before, it's very repetitive. Okay. So you keep doing your ABC, you keep doing the value of the discriminant.